I would like to welcome you all for a short presentation about Excel project Applause use case 2. I'm Nishant Malik.
And I'm Dirk Meyer.
In this use case, we are responsible for fabrication of a thermal image sensor. So we start by designing and fabrication of a ROIC. Then we fabricate MEMS bolometer structures on the ROIC. The main focus of the project is the wafer level packaging of these bolometers. So here we do wafer level vacuum package, and also on the cap wafer there is anti-reflective coating, and inside the cap wafer there is a getter material to sustain the vacuum for a longer time. After wafer level packaging, we use 8-inch wafers, we dice them, and then each single die goes on a PCB for advanced packaging. So what we do there is die attach, wire molding, and molding, leaving the window on the top intact, as you can see over here. Finally, we use these single chips in our final demonstrator. So the target of the demonstrator is to capture images and videos in infrared region. So an image would be something like the one showed here, a hand and a radiator you can see behind glowing. So the idea is to get an image like that. Last year for EFECS we also did a short presentation where we explained a bit the physics behind the infrared image sensor. So you are welcome to go to Applause YouTube channel and watch that presentation as well, and a small URL is given over here. In our use case, it's a collaborative work of various research organizations, SMEs, universities, and large corporations all across Europe. On the slides, you can see different partners which are available in our use case. Now I'll give the presentation to my colleague Dirk Meyer, and he will say a few words about the thermal sensor.
Well, I will just repeat in other words what Nishant already told you. So here we see the image of our readout integrated circuit. It's just one die that is cut from the 8-inch wafer, and I will walk you through the build-up of this thermal image sensor. Before the die is diced from the wafer, we actually attach the cap. So I just show one cap here, and that cap has a cavity. Under that cavity there are the microbolometers, VGA resolution, 17 micron pitch, and in that cap we have a getter material which I'm turning on and off here. The getter material is there to really make sure that there is a vacuum. Of course the cap is hermetically sealed to the ROIC, and after dicing, this assembly or this device is attached to a small circuit board which you can see here. On the back side there's a land grid array for future assembly to yet another proximity electronic. The ROIC is wire bonded to the PCB, and still on a PCB panel these devices are molded, where it's important to have an opening for the thermal radiation to enter to the bolometers. So this device will be mounted to proximity electronics, which is put into our camera prototype combined with the optics, and with that we are going to take thermal images. And if you are interested to learn more, I welcome you to contact us at our virtual booth at this conference, or write us an email at ideas.no.
Thank you.
Thank you.